Okay, so I was watching Michigan Rocks, a lot of YouTube videos by, well, he's just a jewelry sort of guy, but also other guys that know a lot more stuff. They keep talking about agates, and I don't know what an agate is, and gee, they look pretty cool. So I went to see if I've got some agates, and I've got this thing here that's labeled as red agates. So from there, we just go down a rabbit hole, unfortunately. So what the hell are agates? As you'd expect, always start with silicon dioxide. This is the rabbit hole that I've gone down. Let's go back to the top. As you'd expect, nothing in rocks makes sense without analyzing silicon dioxide. And apparently, some other guy said that you're never going to see this. Well, he's been, some people on the internet have been collecting rocks for 40 years, and he got this off someone else. And so to get a crystal that's that well formed, to be able to catch that little square and then that little rhombus or whatever it is on the left-hand side. So that's a left-handed crystal as opposed to a right-handed crystal. So there's the alpha helix is spinning clockwise or anti-clockwise or one or the other. Okay. So the quartz actually can turn around in helices, okay, just to make things a little bit more complicated. All right, and so that's necessary actually to understand all this stuff, okay. And so as I'm going up here, I'm going to get to here, I hope. The agates are a type of chalcedony. Please excuse all my pronunciations. And so it's made up of quartz and moganite. And so moganite, I think it's a relatively newly discovered. It takes a lot of effort to work this out because it's mixed in with lots of other crystals and stuff like that. Is actually left-handed and right-handed layering. Alternating slices of left and right-handed quartzes. So you have the left and right-handed crystals, and then you can have it layered, and that can occur on a micro or cryptocrystalline. So you need an electron microscope, which only universities have, and 100 nanometers. They are layering, alternated layering. Whereas you can have normal quartz as well, but you just can't see it unless you go under the microscope. Okay, so you kind of need to know those. And just to make things worse, that's for the tiger's eye. If you stretch the crystals out, so this could just be cooling during the day even, because these are tiny fractions, whereas thermal expansion can be quite rapid and crack a rock completely. And so all of these can also be stretched, which just... As I said, there's an infinite number of shapes, so there's an infinite number of possibilities with rocks, and unfortunately they've come up with like an infinite number of names. So Professor Wisely has this big book of words that you'll never get. I think there's like 1 million words in English, and the average, and about 100,000 that are commonly used, and most people only know 20,000. So that's where we are with words. Okay, so... Where are we? So we've got quartz and moganite, which I've just done up here, all right? And there's two of them that are interlinked, and that's chalcedony, all right? Now, so it can be microcrystalline or cryptocrystalline, and it's a mineral. And so once you get down to here, it's rather silly because they're named after just colors. So if it's black and white layering, it's onyx, and there's a whole heap of stuff, all right? But generally, agate... where's an agate? This one here must be agate, because if you have a careful look, it's got bands. And so that's it. That's what an agate is. It's just bands. Okay? But if there are no bands, it's something else. So this is sort of see-through. But if it's sort of see-through with no bands, like that one. So mind you, I bought this at a shop, then they said this is all agate. Red agate. There's no lines in this. And so that is jasper. There's different types of jasper. That one's carnelian because it's red. God knows what it is if it's not red. Okay? And so light, that's transparent, but there's no bands. All right? Now, jasper is just the same thing, except for there's no bands and it's not see-through. And if you have a look at those inclusions up close, you can see it looks very much like hematite. So all of the redness basically comes from iron oxides causing the red, the iron. Okay, and so that's it. That's the difference. All right. So if it's got inclusions in it, the light, it's irregular and the light can't pass through, and so it's just a red rock made of quartz, and it's jasper. If it's just got impurities, so it's still crystalline, so they're probably in a repeating pattern, the light can still pass through, and so that is carnelian, not jasper, because it's opaque. It's translucent, not opaque. So light can go through. Opaque light cannot go through. All right. But if it's either of those, see-through or not, and it's got bands, it's where's one with bands? That one does have bands on it, but I'll talk about that in a sec. This, and you can see it close up, perhaps. There's banding on that. That is an agate, just agate, because it's got bands. Maybe a red agate. Careful on the colours. If it's black and white, it's not agate. It's got its own name. There are a million names. The names never end. This one here, you can see the crystals macroscopically. So by definition, that would now be quartzite there, and it couldn't be agate because it's not microcrystalline or cryptocrystalline. But that at the top here, I can try and focus in on that. You can see up close with the other view, sort of the microscope view, you can see that there are banding there, and you still can't see the crystal, so it could be cryptocrystalline, so it's half of it's agate, half of it's quartzite. So half of it's mineral, half of it's rock. Welcome to the world of rocks, where there's an infinite number of possibilities and combinations, and yet they try and put things into discrete categories. It's very unscientific, the whole earth science thing. I'm very unimpressed. They really need to take a chemistry point of view rather than a biology, let's just name random things and not understand anything. And so that's jasper because it's opaque. And then I think we're done, okay? So now I know what agates, jasper, and carnelians was. So when I went and bought this packet here that was agates, and I asked these guys questions too. They got no idea. They pretend they know and just make stuff up, which unfortunately teachers do that too, by the way. Don't trust your teachers. So that's a range of rocks there, okay? I'm not going to say it's quartz because pretty much everything's quartz. It's hard to find something that's not quartz. Good luck. In the top corner, they're not technically quartz, although they probably came from quartz, the amphiboles. So going on to tiger's eye is still going down a rabbit's warren. So tiger's eye has banding too, and it's made of quartz. So good luck on that one. It does have one unique feature. Here you can see that it's got this weird reflective. Oh, and it's brown too, yellow and browns. If you go up close, I've got the bending right. It takes a bit of effort to find it and get it on the camera. To see that it's called chalcedony, chalcedony or something, all right? Chalcedony, it's not chalcedony because that's a type of rock, but the feature, unfortunately, it's the same name. Although this is not a chalcedony, it's a tiger's eye. So the agates, onyx, and jaspers, carnelians are all minerals, and now we've gone to a rock, and it's also a metamorphic rock because it's not just the quartz, it's mixed in with some iron minerals. That's why it's got that brown, that dark reddish, the black layers and that sort of reflective thing to it as well. So you can see how grey all these areas are. Okay, so there are three main ores: magnetite, hematite, limonite. And limonite usually is from weathering of magnetite and hematite. There are some pictures of it. And so this one's a limonite. The AI version says it's this amphibole. So these, I've just talked about hornblende as the amphibole, but there are these lesser common amphiboles. And some of them break off and form fibres, and that's asbestos, and that can kill you. Thankfully, it's not many of those, although this one, crocodilite, is one of them. And so that apparently gets metamorphosized and the iron oxides are left behind and then replaced with silica. And that's the AI version as well. And then you go down the rabbit's hole, Warren, of ResearchGate, and the professors us trying to argue and trying to explain it as well. So that's when you know you're really gone down a difficult path, when you're going to try and explain how that forms and the nature of it. But at least I know one's a rock, one's a mineral. And it's been that the iron comes from a replacement by the silica, and that's somehow how you get that feature. All right, unfortunately, that just gives me more questions than answers.